Hi, this is Dana Maier, and I am doing my week 3 assignment for Material and Methods 2, and it is on sustainability in wood construction. Wood, a sustainable material for construction. Wood is a versatile raw material and the only renewable construction material. Wooden structures are usually characterized by a combination of different components that together deliver the best possible load-bearing capacity, thermal, acoustic, and moisture insulation, fire resistance, and a long service life. Increasing the proportion of wood in construction can facilitate a reduction in the use of other construction materials such as concrete, steel, and brick. These construction materials don't come from renewable raw materials. They require a great deal of energy for their production, and they entail higher emissions of carbon dioxide. Production of different construction materials. Manufacturing wood products require the input of very little external energy over and above the energy from their own byproducts. 80% of the energy consumed by Sweden's sawmills derive from biofuels from their own production lines, such as bark and shavings, while 20% is electrical energy. When manufacturing other construction materials, the starting point is always finite raw materials. Both extraction and processing require energy, often in very large quantities and from fossil fuels. The manufacture of cement generates substantial carbon emissions, as do the processes for making steel. All the construction materials produced by these processes therefore have a positive carbon footprint. This measure of product or activities emissions of carbon dioxide and other greenhouse gases helps the user to opt for the alternative with the lowest impact on the climate. Wood is a carbon negative since carbon dioxide is stored in the original wood, and the emissions associated with harvesting, transport, and processing are still small compared to the quantity of the stored carbon dioxide. And here's also a diagram showing the difference in the various materials. Wood to replace other construction materials. Wood can replace other construction materials in many structures while providing the same functionality. One example is that in the Swedish bridge standards, Branorm, wooden bridges can be designed for the same function and service life as steel and concrete bridges. Such a material substitution could bring significant climate benefits where wood replaces materials whose production requires fossil fuels and causes high carbon emissions. Environmentally efficient life cycle and ecocycle. All construction materials except wood have a single ecocycle that involves reuse. For wood, there are two ecocycles, a shorter one that reuses the component or material, and a longer one that reuses the constituent parts of the wood material via nature's ecocycle. We see examples of the shorter ecocycle in the construction industry and in distribution and packaging. Windows, doors, and timber can be reused, as can pallets, packaging, and cable drums. In all cases, there is an organization to deal with the products and find new users. Once wood can no longer be reused or its material recovered for use in fiberboard and other sheet materials, for example, it can still generate energy through incineration. The energy is climate neutral and is in fact stored solar energy. Building with wood, it's positive for the climate. Achieving a climate neutral society depends on a greater energy efficiency and a wider use of renewable energy sources. For the construction and real estate sector, this will have an impact on both the production and use phase. For new builds, this is about the choice of materials and having a construction process with a low environmental impact and an energy efficient building at the end of it. For existing buildings, the focus will largely be on energy efficiencies, since the environmental impact of the construction phase has already happened. Historically, a building's operational phase has accounted for the greatest energy consumption during the building's lifetime, and the production phase has been seen as almost negligible. With the advent of new, increasingly stricter requirements concerning energy use in our buildings, and in an extreme case, zero energy buildings, energy use in the production phase will become increasingly important. Adapting material choices, designs, and production processes to the new conditions is a major challenge for the construction sector. Greater use of wood-based products and wooden structures is a significant part of the solution due to the material's carbon storage and substitution effects. Standards and environmental product declarations. New standards and documents are currently being drawn up as a means of assessing a building's environmental impact. The basis for all standards on the environment is ISO 9001 and ISO 14001. Then come the standards for life cycle analysis. Production Category Rules, or PCR, is setting out how to draw up an environmental production declaration, and these are governed by the SS-EN 15804 for building products. SS-EN 15978 specifies the calculation method based on a life cycle analysis that is used to assess the environmental performance of the whole building. Now we will talk about tree growth. Trees grow in height as a result of the meristems that are located at the branch tips. All buds that you see on a tree contain apical meristems. Trunk diameter growth occurs as a result of another meristem, already mentioned, called the vascular cambium. A tree grows upward from the tips of the branches, downward from the roots, and outward from the trunk. The root anchors the tree to the ground, and the trunk gives support to the branches. As a tree grows from the food it manufactures, it adds new layers of wood to its trunk. Because one is formed each year, these layers are called annual rings and may be used to tell the age of a tree. The center of the stem is called the heartwood. This is composed of dead cells that give the tree strength to stand. The heartwood was once sapwood, but when new sapwood formed, the older died and formed the heartwood of the tree. Many wood-using industries today are doing an excellent job of managing their forests and harvesting the trees so that other trees will grow and replace those which were removed. This practice, known as sustainable forestry, assures that we will have the trees of a variety of species and sizes growing forever to make these products we need in our daily lives. Softwoods and hardwoods. All trees reproduce by producing seeds, but the seed structure varies. In general, hardwood comes from a deciduous tree which loses its leaves annually, and softwood comes from a conifer, which remains evergreen. Hardwoods tend to be slower growing and are therefore usually more dense. Hardwood is not necessarily a harder material, and a softwood is not necessarily a softer material. Different types of construction projects call for different kinds of timber. Both hardwood and softwood are used for everything from structural to decorative. Softwood and hardwood are distinguished botanically in terms of their reproduction, not by their end use or appearance. All trees reproduce by producing seeds, but their seed structure varies. Specifically, hardwood has vessel elements that transport water throughout the wood. Under a microscope, these elements appear as pores. Hardwood is more likely to be found in high-quality furniture, decks, flooring, and construction that needs to last. Types of hardwood are alder, balsa, beech, hickory, mahogany, maple, oak, teak, and walnut. More details on softwood. They usually has needles and cones, medullary rays and tracheids transport water and produce sap. When viewed under a microscope, softwoods have no visible pores because of tracheids. About 80% of all timber comes from softwood. Softwoods have a wide range of applications and are found in building components, for example, windows and doors, furniture, medium density fiberboard or MDF, paper, Christmas trees, and much more. Types of softwood are cedar, Douglas fir, juniper, pine, redwood, spruce, and yew. Now we will talk about certified wood. Certified wood and paper products come from responsibly managed forests as defined by a particular standard. With third-party forest certification, an independent organization develops standards of good forest management, and independent auditors issue certificates to forest operations that comply with those standards. Some certified wood requirements. Forest certification programs typically require that forest management practices conform to existing laws. Other basic requirements or characteristics of forest certification programs include the basic requirements of credible forest certification. Such items include protection of biodiversity, species at risk and wildlife habitat, sustainable harvest levels, protection of water quality, and prompt regeneration. There are third-party certification audits performed by accredited certification bodies, publicly available certification audit summaries, multi-stakeholder involvement in a standard development process, and there's also a complaints and appeal process. Today, there are more than 50 certification programs worldwide addressing the many types of forest and tenures around the world. Two of the largest international forest certification programs are the Program for the Endorsement of Forest Certification, also known as PEFC. It is the largest certification framework in terms of forest area, with approximately 2/3 of the total certified area. And there's also the Forest Stewardship Council, or FSC, and it is the fastest growing. Sawing. Forest certification programs typically require that the forest management practices conform to existing laws. Seasoning. This is also known as wood drying. Also could be called seasoning lumber or wood seasoning. This reduces the moisture content of wood before its use. When the drying is done in a kiln, the product is known as kiln-dried timber or lumber, whereas air drying is the more traditional method. Seasoning when it is done in woodworking. There are two main reasons for drying wood. First is woodworking. When wood is used as a construction material, whether as a structural support in a building or in woodworking objects, it will absorb or desorb moisture until it is in equilibrium with its surroundings. Equilibrium, usually drying, causes unequal shrinkage in the wood and can cause damage to the wood if equilibration occurs too rapidly. The equilibration must be controlled to prevent damage to the wood. When wood is burned, it is usually best to dry it first. Damage from shrinkage is not a problem here, and the drying may proceed more rapidly than in the case of drying for woodworking purposes. Moisture affects the burning process, with unburnt hydrocarbons going up the chimney. If a 50% wet log is burnt at high temperatures with a good heat extraction from the exhaust gas leading to a 100 degrees Celsius exhaust temperature, about 5% of the energy of the log is wasted through evaporating and heating the water vapor. With condensers, the efficiency can be further increased, but for the normal stove, the key to burning wet wood is to burn it very hot, perhaps starting a fire with the dry wood. Surfacing. To know what the actual measured thickness is, you need one more identifiers such as the S2S or RGH. S2S means surfaced, two sides, and RGH means rough, and they describe the stage the lumber is in, surfaced or rough, but all lumber starts out rough. What do these lumber fractions mean? In short, these fractions are the names for the thickness of the hardwood lumber. The thickness is expressed as a fraction and goes in increments of quarters of an inch. However, this fraction is more of a name than it is a precise measurement. It tells you approximately how thick the lumber actually is. Lumber defects. Defects in lumber are faults that detract from the appearance and utility of the wood. Some are present when the wood is produced, and others develop or become more severe as the wood ages. As a general rule, you can reduce the amount of defects by purchasing a higher grade materials at the outset. Properly drying the wood before it is installed will also help. Using protective strains on your deck can prevent some damage to the wood by slowing down the drying process in order to limit checking. Stains can also conceal visual defects by covering them with a consistent color throughout the deck. Defects in lumber are faults that detract from the appearance. Check. A check is a term used to describe a crack that runs through a board, usually running lengthwise. It is usually caused when lumber dries too quickly. Adding a UV protective stain can help protect decking and rails. Checking often affects pressure-treated framing materials, as they are usually sold very green and are put under a lot of stress as they dry out in the sun. Thicker members like 6x6 posts tend to dry out unevenly and are especially susceptible to extreme checking. Wood reacts differently in various climates across the U.S., and different species and grades also have differing appearances. Exterior environments have fluctuating moisture content in the air and materials. Whether in a dry or wet climate, there will still be annual variation. With a typically large cross-section of posts, commonly 4x4 or 6x6, the lumber does not dry uniformly. As the wood dries, it shrinks, and shrinking often causes existing cracks to open or twisting to occur. This is normal and structurally acceptable in most cases. Pecking is a strange phenomenon found in certain woods, like cypress. This appears on lumber as a cavity or pitted area in a board caused by a parasitic fungus when the tree is still alive. The decay stops after the tree is cut. The result is an unusual textured surface. A little more on decay. Rotten decay is a general description for the disintegration of wood fiber. Decay is caused by a microscopic organism like mold and fungus that feed off of the natural substances found in wood. Fungi require four conditions in order to survive: an oxygen supply, 40 to 100 degrees Fahrenheit temperatures, a supply of moisture — most fungi need moisture and content of 30% or more to thrive — and a food source. Some woods, like cedar and redwoods, have extracts in their heartwood that make them naturally resistant to decay. We will talk more on shake now. Ring shake is caused by a parasitic bacteria that weaken the wood and results in cracking between and parallel to the tree's growth rings, resulting in lower strength. This is much like a large straw with a small straw inside of it. If it is stood upright, it can fall out of the bottom. Ring shake can also cause a dark discoloration and unpleasant vinegar or rancid odor. This defect usually occurs in the wood with high moisture content. It takes a long time for shake to spread, so it is usually found only in the lower part of the trees and can be cut out. Pitch pocket. These conditions are seen as a pocket of bleeding, resinous material found on a board and occur when a tree is injured. It sometimes happens when a feeding insect damages the living part of the bark. Resin or sap can stain lumber and may cause difficulty when applying finishes. Another defect is wane. This is the presence of bark or the absence of wood on the corners of a board This defect will only be found in lower grade lumber. You may be able to turn the board over to conceal this kind of defect in some applications. Another one is crook, or also known as crown, and it is a defect found in a board that is bent end to end in the direction of the tall ends of the board as it continues down the length of the board. It can occur from uneven drying or if the tree's pith, which is a soft core at the center of a tree, is at the edge of the board. Another defect is bow. A bow is a defect in the board that bends along the grain lines. If the board were laid across a flat surface with ends in it, both ends would be in the air. There is no warp across the grain. This can be caused by uneven air circulation during as the wood dries. Any bowing causes internal stresses that will make the board difficult to cut. Cup. Cupping occurs when the board bends edge to edge across the face of the board and where the ends of the boards look like the letter U. It is common in boards that are cut close to the pith. Twist. Twisting is a general term for a board that bends in any variety of directions and cannot maintain a straight line. Sometimes one corner doesn't line up with others. It usually occurs when the wood grain pattern is not parallel to the edge. Also, we have manufacturing defects for decking. These are defects found in lumber that are caused by sawing and dressing lumber. The machining process to produce dimensional lumber puts a large amount of stress on wood. In trying to reshape a large, uneven log composed with complicated grain patterns into the usable lumber can cause reactions that produce lower quality timber. A couple things that apply to this are roller chuck, skip, and machine burn. We will now talk about lumber grading. A general guide to basic wood. The two main classifications of lumber are select lumber and common lumber. Select lumber is considered the finest and best for use in finishing projects. Common lumber is best for general building and construction. Select lumber classifications. There are natural finishes, and they are graded either A or B. A is nearly free of all defects and blemishes. B contains a few minor blemishes. Painted finishes are graded either C or D. Grade C contains more significant blemishes and more of them than woods in grade B. Grade D has even more blemishes than grade C does. Either grade C or D presents a satisfactory appearance when painted. Common lumber classifications. There's a number 1, which is for construction use, and is sound, tight knotted stock containing only a few minor defects. It has no knotholes or other serious defects. It may be suitable for use as a grain-tight lumber used for siding, cornices, shelving, paneling, and some furniture. There's number 2, which is standard use, and this grade has more and larger knots and blemishes than number 1. Number 3 is utility use and contains a few defects larger and coarser than those in number 2. Number 4 is a low quality material, contains serious defects like knotholes, checks, shakes, and decay. Number 5 commonly holds together only under ordinary handling and where appearance is not important. This kind of wood is not paintable. The first 3 grades, 1, 2, and 3, are commonly available in retail lumber yards. This is a picture of a structural property of wood where you see a lot of cracking, and the structure is in question. Lumber dimensions. We have here nominal versus actual. Directional lumber is cut to a specific length, width, and depth. However, there is a difference between the nominal size, which the lumber is referred to, and the actual size. The tables below provide both the nominal and actual sizes and we have it for 1-ply lumber and 1-by lumber and 2-by lumber. We will now talk about glue laminated wood. Glue laminated timber, or glue-lam, is structural engineered wood element commonly used for beams and columns in residential and commercial applications. Glue-lam is a highly visible form of mass timber in contemporary projects, with long spans framing signature designs that have been left exposed to take advantage of the wood's natural aesthetic. Structural composite lumber. We have the first main one is SCL, or structural composite lumber, and this includes laminated veneer lumber, LVL, parallel strand lumber, PSL, laminated strand lumber, LSL, and oriented strand lumber, OSL. And they are a family of engineered wood products created by layering dried and graded wood veneers, strands, or flakes with moisture-resistant adhesive into blocks of materials known as billets, which are subsequently resawn into specified sizes. In SCL billets, the grain of each layer of veneer or flakes runs primarily in the same direction. The resulting products outperform conventional lumber when either face or edge loaded. SCL is a solid, highly predictable, and uniform engineered wood product that is sawn to consistent sizes and virtually free from warping and splitting. Common SCL applications. Typical uses include rafters, headers, beams, joists, studs, columns, and I-joist flange material. 2 or 3 sections of SCL can be joined together to form a 3 1/2 inch or 5 1/4 inch members. These thicker sections readily nest into 2x4 or 2x6 framed walls as headers and columns. SCL sizing, 3/4 inch to 3 1/2 inch thick, depths and lengths to match the end use. A little more on laminated veneer lumber. It is widely used structural composite lumber product. It is produced by bonding thin wood veneers together in a large billet so that the grain of all veneers is parallel to the long direction. Popular LVL applications include headers and beams, hips and valley rafters, scaffold planking, and the flange material for prefabricated wood I-joists. Oriented strand lumber is another one. Similar to LSL, oriented strand lumber is made from flaked wood strands. The strand geometry for OSL results in length to thickness ratios approximately 75. Combined with an adhesive, the strands are oriented and formed into a large mat or billet and pressed. OSL is used for a variety of applications from stud to millwork components. Now we will talk about wood plastic composite decking and non-structural lumber. Wood plastic composite, also WPCs, are products made from wood lumbers and plastics of various types mixed with other ingredients such as ultraviolet stabilizers, pigments, lubricants, and biocides, which are then heated and pressed, extruded, or injection molded into a final form. In comparison to their solid wood counterparts, WPC materials offer more consistent material quality, freedom from defects and distortion, and depending on their formulation, superior resistance to moisture. They are used most notably for exterior decking as well as exterior railing systems and finish trim, both interior and exterior. Like structural composites, WPC products make productive use of rapidly renewable or waste materials. Some WPCs have high recycled materials content. Another item is plastic lumber. Plastic lumber, known as PL, is a plastic form of lumber made from a virgin or recycled plastic. It is made of 100% plastic compared with wood plastic composite lumber. Widely employed in outdoor decking, it can also be used for molding and trim and garden furniture such as park benches. Resistant to cracking and splitting, When appropriately installed, plastic lumber can be molded with or without simulated wood grain details. Even with a wood grain design, PL is still easy to distinguish visually from natural timber. The grains are the same uniform colors as the rest of the material. Manufacturers claim plastic lumber is more environmentally friendly and requires less maintenance than wood plastic composites or rot-resistant wood. Unlike wood plastic composite lumber, plastic lumber is 100% recycled after its original intended use. Wood panel products. Wood panel products are flat, sometimes curved, sheets made from wood-based materials that are bonded together with an adhesive. Panels are typically of veneer strands, particles, or fibers that are bonded with a synthetic or other adhesive cured using heat and pressure. The properties of the panel products are a result of the character of wood, raw material, the adhesive, additives, and the details of the manufacturing process. The most commonly produced wood panel products are plywood, oriented strand board, particle board, and fiberboard. Other wood-based composite materials may be produced in panel form for specialized applications and markets. Wood panels may be categorized as a structural or non-structural. Structural panels are designed and manufactured to resist forces and play specific roles in structural systems such as houses, buildings, concrete formwork, shipping containers, and unit load platforms. Mechanical properties are principal design criteria for these products. Non-structural panels are typically produced for other than structural applications such as furniture, flooring, and doors, and where other properties besides strength and stiffness are important. A little more detail on wood panel products. Specifically, we have plywood, and it is a panel product made by gluing individual plies or thin layers of veneer together. The veneer is a thin sheet of wood that has been mechanically peeled from a log on a lathe in a fashion similar to unrolling toilet paper. Plywood is made from both hardwood and softwood species and may be bonded with many types of adhesive. Oriented strand board, or OSB, or wafer board is comprised of thin wood strands or flakes that are sprayed with resin and wax, formed into a mat that is pressed under heat. Individual flakes and layers of flakes are oriented in different directions in the lay-up process to achieve desired properties, hence the name. OSB panels are used much like plywood as a sheathing material, and OSB is seen as a lower cost substitute in many applications and markets. Particle or chipboard is a panel product made from wood particles that are sprayed with wax and adhesive, formed into a mat and then pressed under heat. Particle board can be made with very smooth surfaces that allow surface coatings, veneer, overlay to be added that form decorative or working surfaces. We'll now talk about wood chemical treatments. Wood preservative products are those that claim to control wood degradation problems due to fungal rot or decay, sap stain, molds, or wood-destroying insects. Both the treatment process and the use of the treated products can result in exposure to pesticides for both people and the environment. Most of the treatment processes and uses of treated products occurs outdoors. There are wood preservatives that support a tolerance for indirect food contact uses such as wooden crates, pallets, and stakes used to store or grow raw agricultural commodities. Generally, fresh-cut logs or lumber are treated and then manufactured in products such as seasoned building materials, utility poles, fence posts and rails, structural members, structures and dwellings, transportation vehicles, crop containers, lawn furniture and decks, playground equipment, garden landscape timbers, log homes. Manufactured wood components. Engineered wood, also called composite wood, man-made wood, or manufactured board, include a range of derivative wood products which are manufactured by binding or fixing the strands, particles, fibers, or veneers or boards of wood together with adhesives or other methods of fixation to form composite materials. Some advantages are engineered wood products are used in a variety of ways, often in applications similar to solid wood products. Engineered wood products may be preferred over solid wood in some applications due to certain comparative advantages. Because engineered woods is man-made, it can be designed to meet application-specific performance requirements. Engineered wood products are versatile and available in a wide variety of thicknesses, sizes, grades, exposure durability classifications, making the products ideal for use in unlimited construction, industrial, and home project applications. Engineered wood products are designed with manufactured to maximize the natural strength and stiffness characteristics of wood. These products are very stable, and some offer greater structural strength than typical wood building materials. Other items are glued laminated timber has greater strength and stiffness than comparable dimension lumber, and pound for pound is stronger than steel. Some engineered wood products offer more design options without sacrificing structural requirements. Engineered wood panels are easy to work with using ordinary tools and basic skills. They can be cut, drilled, routed, jointed, glued, and fastened. Plywood can be bent to form curved surfaces without loss of strength, and large panel size speeds construction by reducing the number of pieces to be handled and installed. Engineered wood products make more efficient use of the wood. They can be made from small pieces of wood, wood that has defects, or underutilized species. Wood trusses are competitive in many roof and floor applications, and their high strength-to-weight ratios permit long spans, offering flexibility in floor layouts. Additionally, engineered wood is felt to offer structural advantages for home construction. Sustainable design advocates recommend using engineered wood, which can be produced from relatively small trees rather than large species of solid dimensional lumber, which requires cutting a large tree. And here is a list of references.